share the unit spec. So what you're going to probably see is a big screen, but let me just get it down to a manageable size. There we go. So are you able to see the unit specification now?
Yeah, I can see it. Yeah.
Okay, that's great. Now, so normally when we, look at some queries, some details which are obviously, say, for example, queries at your end or where you're getting stuck. What I want to do is obviously look at some of the basic areas where, we can cover some part of the unit and unit content, and then look at some of your queries which will be related to specific tasks or questions.
Okay.
Is that okay? So let's look at. So how do you want to start? Have you gone through the presentations?
Yeah, I've gone through the first one, but I've done the first bit, the 1.1, discussed the language and symbols associated with set theory in context of probability.
Yeah.
But then the represent and interpret probabilities using tree diagrams, Venn diagrams, and two-way tables is I'm kind of struggling with just what I need. Like, I don't know how to do diagrams on Word or anything like that.
Sure.
If that makes sense. And
Sure.
I can't seem to find the content to explain. Obviously, on the brief, it says for number 2 is to calculate the following, and a bag contains 44 red balls and 55 blue balls. Basically, do the calculate the probability. I just don't understand where to start with that, if that makes sense.
Sure. Okay. So basically, what I will do is there is, say, for example, a formula sheet that we have. So there are some parts in the assignment brief. If I bring that also into quickly the discussion, and so what we'll do is we'll look at some part of it, which I will share with you just after the session on the email. So this is the bit where you are, I think the assignment brief is a better, ready reference guide, because it gives us what we need to look at from a unit's perspective, and also tells us what are the questions or tasks that we need to do, in this unit. Now, generally speaking, the part which you picked up, which is 1.1 and 1.2, is actually covered here. So essentially, what we want to be able to do is have a bit of understanding in terms of, how do we calculate probability, look at the formula of probability, and then we should be able to address in terms of, some of the tasks and questions. Now, there is a bit which basically talks about discuss language and symbols associated with the set theory, which is primarily, a theoretical framework, and that is something which also you would need to look at to understand why it is used. So when we look at set theory in mathematics in particular, this tends to be a branch of mathematical logic which allows us to understand, making choices when we are dealing with objects in particular. And these objects could be various forms of objects. So these objects could be essentially, things that we generally come across when we are essentially, out and about. Say, for example, a simple one that I would give you is if you're in a lift. Now, one of the things that as an object that you would do in the lift is to press the button or use the buttons to go onto a particular floor. So when we do talk about, set theory, it is going to be looking at helping you understand how do you look at dealing and start making choices when you're dealing with a collection or a set of objects, which then translate into some sort of mathematical calculations. So sticking to that example of lift, when you press that button, say if you press 4, obviously in the background, there is some sort of mechanics which typically tends to work, or electronics which tends to work, and it tells the lift that you want to go up to the 4th floor, and it starts closing the door, and obviously you go up. So the bit which relates to, a bit of theoretical understanding on this would be to get to, understand this framework of set theory, which is primarily used to deal with when you have a collection or a collection of objects, and these objects essentially would allow you to make some choices. Now, without going into details of that theory, what we also want to look at is how this is used in the context of probability, because set theory, if you read, is a handout that I can provide to you just after this session, and that would give you various context of how it was initially proposed. What is the modern version of it when it was initially proposed by the German mathematician Richard, and what is the current combination of or context of this theory, which is used typically in, say, gaming scenarios or in situations when you look at dealing with a lot of choices. So, for example, a lottery, if you play the National Lottery or Euro Million, that also has a bit of a usage of what is called the set theory. So, what balls are picked out, how electronic picks it up, and what kind of number arrangement typically follows. You give some variables, which is numbers 1 to 60. Then you have them, in a container wherein it rotates and all that stuff, and then you press a button, it picks one out and brings it out. But although that is done, using a machine, because we're talking about a lottery in this context, so this involves probability. If there are 60 numbers, it could be any of one of the 60 numbers which could get pulled out when you press the button each time to arrive at a winning number for the lottery. So there are lots of uses of set theory that we can actually use and kind of use, and they are typically used in different scenarios where you have a collection or a number of objects or collection choices or multiple choices that you have to make. And from that multiple choices, you have to pick one depending on which works best in terms of that particular situation. Now, what we want to be able to do is understand this in the context of how probability works. Now, probability is a simple example that I would give you is obviously it's snowing and there's bad weather outside. So what is the probability of it snowing today? So we know that there are 7 days in a week. So if I'm talking about what is the probability of it snowing today, which is we are looking at Thursday. So it is 1 out of 7 because that is the day that I'm talking about, and it is one of the days of the week. So 1 out of 7 will be the probability that it might snow. Now, how do I look at arriving at that probabilities? I would also look at sometimes old statistical data, that what was the temperature and the weather conditions last year, maybe vis-a-vis last year, a couple of years back. And then what we can do is obviously calculate what is the probability of it snowing in January in Manchester, for example. So last year, probably we had snow in February. There was no snow in January. If I go back another year, probably there again no snow in January or during Christmas. But if I go back to 2010 or 11, there was a lot of snow, and there was about a foot of snow in Manchester during that year. So if I have to look at now calculating probability of it snowing and predict that for 2026, and I have a reference set of say 10 years, then in that case, what I would do is use that reference set of 10 years. And out of these 10 years, we've seen that in January, 3 out of these 10 years, it snows in January. So if I have to now predict what will the probability of snowing in January 2026, I will use that reference set, and that is where the set theory comes in. But obviously, to calculate the probability, and we'll go down to that question as well, there is a formula which is typically applicable, and probability is always 0 and 1. There are only two sides to a coin, either it's head or tail. So when you flip the coin, chances of it coming and standing in the vertical without giving you either head or a tail is 1 in a billion. So when we calculate probability, it means 0 and 1 kind of a situation. 0 means that the event or the situation will not happen, and 1 means that the event will happen or the situation will happen. So the calculation in terms of formula for probability is very simple. It looks at number of favorable outcomes divided by the total number of possible outcomes. So when I look at asking you a question that what is the probability that it will snow in January? Now, what are the total number of possible outcomes? There are 31 days in January, right? Because I've given you a month or a set to work with. So we are talking about month. If I talk about a year, what will be the set in that case?
If what, sorry?
If I say what are the chances of snowing this year, what will be the total number of possible outcomes that you would get?
365.
That is correct. If you look at
Yeah.
it from a day point of view, if you look at it from a month point of view, it'll be 12. If you look at it from a week point of view, the total number of possible outcomes that might snow in 2025 would be, say, 52 weeks. So probability is calculated by looking at number of favorable outcomes divided by the total number of possible outcomes. That's a simple formula how on using which how you calculate probability. Now, when we do talk about event, that is where set theory comes in. So when I say define an event, event is event where there is a probability that you have for that event to happen. So what is the probability of the train actually going from Manchester to London and reaching on time? We will have to find out how many trains leave Manchester for London every day. And depending on those number of total possible outcomes, we will then be able to predict or look at finding out a probability of how many such trains will reach on time. If there are 10 services from Manchester to London during the course of the day, then the probability will be 1 or 2 or 3 out of 10, and that will depend on measuring how many such times has the service reached on time in 2 hours and 8 minutes. For example, if I look at Virgin trains, then the travel time which they provide on their website is 2 hours and 8 minutes to London from Manchester. And that is from Manchester Piccadilly to Euston. So we know what is the defined location. We know what is the favorable outcome. We know how many services are happening between Manchester to London on a daily basis. And then what we can do is use the probability formula to basically apply it and find out the probability of the trains reaching on time. Is that okay?
Yeah.
Now, going into, for example, this particular bit, which is the bit which talks about, the task here, what
Yeah.
we'll be able to do is use this formula and essentially talk about, finding out what it is saying. So it says the bag contains 44 red balls, 55 blue. Rahim picks out 2 balls at random. Calculate the probability that he selects the same colored balls each time, given that each time the ball is selected, it is replaced. So that means you have a sack in which there are, 99 balls, and 44 of them are colored red, 55 of them are colored blue. And if you were to put your Rahim, or if you are to put a hand in the sack and pull out one ball and then pull out a second one, what is the probability that both of them will be of the same color? So that is what you want to find out in this particular context. Now, in order to solve this particular problem, the first thing we need to know is what are the total number of possible outcomes using the formula. What are the total number of possible outcomes? So that would mean what are the total number of balls essentially that are in the sack? That will be 44 plus 55. Correct? That's the total number of balls that you can pull out from the sack, isn't it? So it's 99 in total. Now, once we know that the total number of balls in the sack are 99, the second thing that we want to find out is what is the probability of selecting the same ball each time you pick out one, right? So how do we calculate that? Now that we know using the formula, what is the formula? Formula is number of times you pick out a ball, which is divided by the number of total balls. So if you were to look at picking out a red ball and find out if the first time you put your hand in and you pick out a ball and it comes out red, the probability is going to be 44 by 99. Correct? And if it is going to be a blue ball that you pick out, it is going to be a probability of 55 divided by 99.
Yeah.
Is that okay? Now, because I don't know and I can't predict what I'm going to pick out, this is just on a assumption basis. Now, if I have to now apply probability formula, because there are two scenarios, one is I pull out a red ball and the second is I pull out a blue ball, then what I need to do is do an average or a total of what will be the total possible outcomes and what could be the two balls that are drawn out, and if I draw out the same color of the ball each time that I essentially pick out a ball from the sack. So I've been given two tries, and when you pull out a ball, you look at the color and then you put it back in. So the pool becomes 99 balls again, and then you pick out a second ball again, and then you look at whether that second ball is matching the first color or not. So in this case, if I have to look at the finding out a probability of picking out two red balls at both the times, then it'll be 44 divided by 99 times 44 by 99. And that would be the probability of you picking out a red ball.
So that's what, so that would be 44
times 44 divided by 99 times
divided
44 by 99, because you have two chances to pick out balls, isn't it? So first time you pick out, it is 44 by 99, and you look at it, it's a red ball, you put it back again, and then you shake it, and then you pick out another one, because there are two tries that you're getting. Rahim picks two balls at random, and
Yeah.
that would be also a red ball. So the probability will be multiplied twice because you're getting two chances. 44 by 99 times 44 by 99.
Oh, it's times.
Times, yes. Because there are two tries you're getting, isn't it? You're not picking out two balls in one instant. You're picking out one first, and then you
I
go
thought
back.
it was 44 divided. I thought you divided it by 99.
Yeah, 44 divided by 99 times, that's the first probability. And the second
Right.
probability is 44 by 99 again, because you replace that ball before you pick out the second time.
Right.
Is that okay? So
Yeah.
we're going to multiply. The probability of picking two red balls is going to be probability, if I say P equal to 44 divided by 99 into 44 divided by 99. That's how probability is going by the formula, how it works.
Okay.
So let me just see if I can type it out into, presentation screen that I can show you. 1 second. So assuming we were doing this task, and the probability, formula is probability equal to, I would say number of times an event occurs, and this is divided by, or if I have to put it another way, just looking at, so I draw up a line here. And I say by total number of trials. Now, in this case, what we are looking at is red or blue balls. And then underneath that, what we are essentially looking at is total number of balls.
Yeah.
So total number of balls are 44 plus 55 is equal to 99. So anytime we want to find out a probability, what we are going to do is, if it's going to be red balls, if you are getting one chance, then you will say 44 by 99. If you were looking at picking out a blue ball, then it will be 55 out of 99. Now, this is if you get one try. But now the task is saying he picks out two balls. And what are the chances that he picks out one, looks at the color, puts it back again, then picks out another one and looks at it and put it back into the sack again. So two tries for red ball. If we have to find out the probability, what will it be? 44 divided by 99 times 44 divided by 99, because we are getting two tries. And similarly for blue, what will be the probability for blue balls? 55 divided by 99 times divided by 99. Is that okay?
Yes.
So that would help, solve the first part of it, because what we need to know is the formula, probability formula. And this is the probability formula. We can relate this to, weather, temperature, the example that I've given you for the train times, or, what are the chances that Manchester United will score against Manchester City when they play. There's a 90-minute game. There are 11 players on each side. And, if we want to find out probability of Manchester United scoring against Manchester City, and somebody says that they will win by 2-0, then the probability of that would be total players are 24. And if Manchester City has to score a goal, it will be 11 by 22, 11 plus 11, 11 by 22. And if they score two times, it will 11 by 22 times 11 by 22.
Right.
Is that okay?
Yeah, I think I get that. Yeah.
Yeah. So if now it says find out the probability of Rahim picking out the same color balls. So here we will look at that formula, and that would be, if we were to look at P, which is blue, then what we are going to do is P into 2 reds plus P into 2 blues times 2 blues. Because we can't predict, whether you'll pick out a red ball or a blue ball. I don't know. But what are the probability of this being picked out? That anytime you put your hand in and you pick out two, you get two chances. You pick out either two red or two blues. The question is not asking us to understand that if I pick out one red and one blue, that will also be another type of question. If it says, what is the probability of picking out one red and one blue if you had two tries?
Yeah.
So now what we want to be able to do is, using this formula P equal to, we know what is the number. So if I use a calculator here, 44 times 44 and 1 second times 44. So that's 1936 divided by 99 into 99. And that's 9801. Plus you have 55 into 55. So 55, so I'll do this on the calculator, 55 times 55, and that's 3025 divided by, we know 99 into 99 is 9801. So that will give you the answer of probability of same color balls being picked by Rahim. Is, we can further simplify this. And if I simplify this, so it will be actually 1936 plus 3025, because it's a common denominator. So what we can do is basically add these two values.
Yeah.
And divide by 9801. So 3025 plus 1936. That is 4961 divided by 9801. That's the answer. That's the probability. So if I have to go into details of it, and we have to find out percentage divided by 9801 times 100. So the probability of Rahim picking out two colored same balls is 50.61%. So if you multiply this by 100 times 100, this is what will give you the probability, and that's the answer. So the probability of Rahim picking out two same colored balls is going to be the sum total of two different probabilities, because we've got two different types of events, which is like two different types of ball, red and blue. And what we want to do is look at the total number of events or total number of balls, which is 44 plus 59. And each of these need to be added in order to come to a solution, which is to find out what is the probability that he would be able to pick out two balls of the same color when given two tries. And that probability is 50%, 50.61%.
Yeah. So you got that by doing 4961 divided by 9801.
So
and then times it by
times
100.
it by 100.
And that gives you percentage.
That's correct. So if you look at this, if you don't multiply this by 100, it will be essentially 0.5082. And that times 100 would come out to be 50.61.
Yeah, okay.
Is that okay?
Yeah.
So in this part, basically it is down to the formula. And if you know the formula, then you're able to basically look at solving this particular task pretty much straight away.
Yeah. So how is, because it says using tree diagrams, Venn diagrams, and two-way tables. So
Yes.
So I need to put.
You don't need to represent. No, basically, when you look at the unit specification, the learning outcome says understand underpinning concepts related to analysis of statistics. So here, what we look at is, generally, if you assume, to explain this to you in a little, say, detailed way, assume you are using mathematics, which are numbers essentially, or statistics, some sort of research data, to do some analysis on a situation or a particular situation that you're faced. Now, when you have to use statistics or numbers essentially to do the analysis, at some stage when you create a report, you are also looking at depicting the numerical data using certain forms of outputs. And these outputs that we need to know and we need to understand how they can be used is what is called tree diagrams, which are being mentioned here. There are Venn diagrams and there are two-way tables. So this is a standard, I would say tool, which sometimes we as students, researchers essentially use to depict data that has been collected from the research that we have done. I'll give you an example. If NHS was to do a research in terms of COVID, for example, and I'll show this to you in a picture by inserting it on the slide so that it becomes visually easier. Just give me 1 second. So sometimes what happens is when you have a research report, or say, for example, let's look at a real-time situation. You work within an office. There is a report that the company has bought from IDC or Gartner, and it says that this is the prediction or the trend for example, growth happening. A lot of numbers, some crunching of data which has been done, and they have based it on some sort of research or data which has been collected. But because they've provided you an industry report, which is a summarized and a concise version of it, sometimes it's easier to represent this numerical data or mathematical data in the form of certain output, let's say diagrams. And there are these three different types that you look at generally when you, for example, present such complex data. And this can be done through what is called two-way tables. This can be done through what is called the Venn diagrams. And this can be done through what is called the tree diagrams. Now, I'll explain and I'll show you this on a slide in a second, and you'll get the hang of it. So, and they are used primarily, by us, but sometimes we, also name them slightly differently, depending on the context in which we are actually using them. So let me switch over to the slide. And I have just pulled out a few images from Google to show you. Now, do you see this slide?
Yeah.
Now, when we look at, say, for example, let me just magnify this here. So when we look at, say, for example, certain types of data or, let's say certain type of data that you want to, show, which is collated primarily using a report. Now, what you would do is if you have to grab attention, say, for example, or straight away highlight that in a particular report, which is a 20-page report, what you would use is certain types of tools, or which are called organizational features, which are, types of tools that you would use to attract attention, highlight that data, to show what are the important points that are involved, and people should, or audience that you have presented it to, should recognize that these are important parts of that report. Now, when we look at two-way tables are tables like this. Just as an example, it's a table which basically shows how many, say, for example, if the NHS had gone across to Manchester area and randomly did a survey with 5,000 participants, you want to know how many of such participants which are contributing to sharing their experience with the COVID vaccine, are male, are female, they are at a certain age group. You are looking at breaking it down into certain types of demographics. If they are children, they're elderly, they are male, they are female. Now, how would you present that data? You would use some sort of tables. And those tables would allow you to organize that data and present it pictorially or visually, which will essentially grab attention or immediately make it clear to your reading or readers or your audience what is being presented or talked about. Is that okay? One such form could be done through graph. So when you look at Excel spreadsheets, and sometimes you are, say, looking at maybe attendance analysis or holiday analysis of your employees, if you work within an organization, the HR manager would actually say, okay, we've got 217 employees, and we need to look at how many holidays each employee take. You look at dipping into the calendar, you start collating that data. And then once you have that as a subset in an Excel spreadsheet, what you then do is you draw out a graph to show which months the trend was people have taken more holidays, or in which months how many people have taken how many holidays, have they taken, called off sick or things like that. So that data, when you show visually using a graph, might be more meaningful and more easy to understand than going through an Excel spreadsheet to say, looking at all the names of the employees and looking at how many holidays they took or which months they took and whether they were off sick or that was a booked holiday and things like that. Does that make sense?
Yeah.
Yeah. So in sets, when you are dealing with, in statistics or in mathematics, when you're dealing with large number of numerical data, you need to have tools that will allow you to crunch that data and then actually show it or present it in a logical manner and in a concise or maybe in a clearly understandable manner. And in such cases, we can use different forms of tools like Venn diagrams, tree diagrams, and two-way tables to actually depict that data. Now, on the slide that you see, there are certain different types. Probability diagrams are, sometimes it's easier to visually show to learners what is the probability of, something happening. So if you were playing a game or, you were looking at chances, if there were five of you as friends, and you were looking at buying a lottery ticket, or you were, say, for example, playing a game, you want to find out your probability who would actually win the game. So if there are five of you, which is total number of events, and then you're looking at finding out, say, if 1% or 2% or 3% say that I want to find out what is the probability that I will win. So in such cases, what you will do is basically visually, use the tree diagrams to describe that situation. If two people win, then the probability is 2 out of 5. So you're actually using what is called a tree. You start off with the problem and then you keep branching it down till you arrive at a solution or till you arrive at an end. Just like a flow chart, you start and you go to a stop, but you look at various options like yes or no, and you use various options to eliminate problems. And in such cases, you would generally see tree diagrams or mind maps which are going to be used. Is that okay?
Yeah.
And then when we talk about Venn diagrams, Venn diagrams typically are, if I put it this way, they are essentially, diagrams which allow you to reach what are called logical conclusions if you have a large data set. So in this example that I've, put on the slide, what you generally see is that if I have to find out the probability of certain numbers being picked out in the lottery time and again, then I would use a subset or an overlapping set of numbers which I can see covering or coming out in the lottery for the last 10 results or for the last 20 results and 50 results or whatever way you are doing analysis on. So if I want to look at finding out what could be the best numbers I look at picking out for a lottery, what I would do is go back to the previous set of data and see, okay, in the lot which result which came out on Saturday last week, Tuesday last week, then go back another week, go back 3 weeks, 4 weeks, and see what are the common numbers coming out in the lottery. So if you were to find out those common numbers out of the total set of numbers which have come out in the results, the common numbers will be overlapping in terms of results. And that is what the Venn diagram essentially allows you to visually do it, because what you do is you make two circles, and within those circles, you look at putting in the data or the number set which is overlapping. That means it's appearing in all the results that you've analyzed for the lottery. So you could do it for 2, you could do it for 3, you could do it for 4, but depending on if I was looking at last week only, and there were 2 results, one on Tuesday, one on Saturday, then what numbers appeared in both the draws are going to be in the middle, which is what the Venn diagram will allow you to, let's say, shortlist. And that is showing the frequency of these numbers appearing in the results time and again.
Yeah.
Yeah. So sometimes when I look at buying a lottery, I look at picking up numbers like 25 or 13 or 7 in the lucky draws, 2 or 7 or 4 or 7 or 6 and 9, because when I look at analyzing the results, for various draws which have happened over the last couple of weeks, I generally see that these numbers in some shape or form are actually occurring again. The frequency of these numbers coming again is higher, as against some of the other numbers in the draw. So Venn diagrams are useful to construct when you're looking at 2 or more situations and you want to find out what is the overlap in those situations. And the overlap essentially allows you to understand what is the frequency of this happening time and again. Okay, so this is a statistical tool which is normally used, to visually show, because it's a diagram. It's a visual tool that shows what data or data sets can be overlapping, so that if you have to make a rational decision or a logical decision, because there are too many options to decide on, what you would then do is go with the logical option, and that logical option you will arrive at by seeing what is the overlap of the variables which are making that event occur time and again. And that
Yeah.
is when diagrams essentially come in.
Right. So for this unit, for the 1.2, then I don't need to do diagrams. I just need to explain them. Is that what you say?
That is correct. So if I look
Right.
at studying the unit, what I'm looking at primarily is the aspect of understanding for my own knowledge what is
Yeah.
meant by Venn diagrams, what is meant by tree diagrams, and what is meant by two-way tables.
Right. So I do that, and then the um the problem, the thing about the balls, I
Yes,
can just do that in the way that you just wrote it out
that
with,
is correct. You
as
can
long as it's a mathematical equation.
question. Yeah, that's correct.
Right. That's where I was getting drawn up on, because I thought it meant do that in 3 different diagrams.
No. Because
No, right.
the whole idea is you are studying statistics as a unit or a module.
Yeah.
In that, you need to understand the theoretical aspects of it. Now, they in some cases cannot be literally used for the purposes of drawing out evidence or output. And that is why the tasks which are set in the assignment by the awarding body tend to be done utilizing those frameworks or the background that you've got by studying those frameworks or the topics within that learning outcome.
Yeah, I get it now.
If I was to look at not following the assignment brief and I do the tasks or this particular unit's assignment descriptively, then I would literally be going and describing, okay, what is a set theory and in what context or probability the set theory can be used. Then I would go into showing what are, first talk about tree diagrams, Venn diagrams, and define what are two-way tables, and then actually visually show an example of, like I've shown you on the slide, what is a tree diagram, Venn diagram, and what is a two-way table, and how and when are they used. So that would be literally just going into and understanding the concept of it and doing it that way. But in the assignment brief, the actual practical application of it is being asked to work on, and that is where you would not need to look at theoretically explaining them to me on the assignment, but look at solving a question or a task which will be based on such frameworks covered in the unit.
Right.
Okay.
Yeah. So I don't need to put tree diagrams and stuff on my assignment. I just need to explain what they are.
Correct.
And then just put that, and then do the equation for the problem with the balls.
That is correct.
Right. Okay. Yeah. So that's what, because I'm kind of just doing it a bit at a time, so I don't get too drawn up on stuff.
Oh, that's perfectly okay. This is a bit of an interesting unit and also a bit of a tricky unit for some, because if you love numbers and maths, then obviously you would be able to look at examples and bring them in by, like I did on the PowerPoint slide, or even sometimes use pictures and include it in the example when you're doing it, just to start the interpretation of it, rather than you having to visually draw them using Microsoft Word or PowerPoint as tools, because it's difficult to use and draw them in this software. But sometimes it's easy. Like I picked out the two-way table as an example by searching a quick thing on Google. It might be easy for you to bring it into the document, and then underneath, if you want to explain, you could do that by solving the task or the example.
Yeah. Okay. Yeah. That's.
Okay. The first task talks about languages and symbols used in the set theory. So when I send you a handout of the set theory, what you're going to see is the set theory has certain, let's say, aspects of it which you need to be aware of. So set theory is basically looking at sets, events, looking at total number of events and occurrences. Now that is defined in the mathematical formula by certain symbols, and how you put that across as a language. So for example, just not digressing, but just giving you another example. If you were asking you to, if you drive at the speed of 60 miles per hour and you go from Manchester to Wigan, I want you to find out what is the time taken to reach Wigan if you were driving at 60 miles and the distance between Manchester and Wigan is 24 miles. So you have two variables available, and we are asking you to find the time taken to reach. So speed equal to distance upon time. Now, if I know the formula, speed I know, which is 60 miles per hour, equal
Yeah.
to distance upon time. And distance is 24 miles. I need to find out time. So what I would do is move the t onto this side and the speed underneath, and make sure that the units are compatible. So we are talking about, if I said 60 kilometers per hour and I'd give you the distance in miles, you would have to convert the miles into kilometers first by multiplying 24 into 1.6, because 1 mile is equal to 1.6 kilometers. And then
Yeah.
you same units of comparison. And by using this formula, you'd be able to calculate how much time it took for you when you were traveling at 60 kilometers an hour to reach Wigan, which is 24 miles or so many kilometers away. So similarly here, the language and the symbols are speed S equal to D upon T. So what you would need to do is maybe write the formula of the set theory and then explain each of the symbols. What does the P stand for? What is the element? What is the event? And what are the total occurrences of the event? And that would cover the first part of your task, because it says discuss language and symbols associated with set theory, but you have to do it in the context of probability. So what you will do is, after you've explained the set theory and its symbols and the formula, you would also explain the probability and its formula, and that would cover the task 1.1. And if I go up here, that is what it is asking you to study in the unit for a broader understanding of what are the languages and symbols used with set theory in the context of probability. And that has been converted into a task here. And
Yeah.
theoretical one. So you're writing about it, and there is no mathematical example or calculation involved. But in the second part, in order for you to look at talking about probability, what they've done is they've given you an actual example or a question, and you need to then solve it essentially like I've done on PowerPoint slide, but in the Word document, you'll have to write it down, explain it, and then show what is the answer.
Yeah. Yeah.
Okay. And similarly, if you look at question 3, it says explain the characteristics of different types of data: primary, secondary, categorical, numerical, continuous, and discrete. This is theoretical. So you have to define each of the types of data. What is primary data? What is secondary data? How do you categorize the data? Why is it numerical? And why sometimes we say the data has to be continuous. So for example, when you do questionnaires, you look at a Likert scale. We do end up answering a lot of surveys on phones. The service was very good. The service was good. You remain neutral. You say the service was bad and it was very bad. So what do you mean by continuous data, and what do you mean by discrete data? That is what you need to theoretically, cover it by taking on the definitions here. And then asking you to do, practical part of it, to say, interpret the following board demographics representing board members in a multinational company. So using this picture, it is asking you now to identify and talk about that. If this was visually shown to you and the question given was, can you now interpret what is being shown in this picture? You have to write about it. So the first pie chart here actually shows you race demographics. That means people working within the board of this company, which has 13 board members, 69% of them are white, 15 are Asian, and so on and so forth. Then they look at gender, male, female. There's a breakup again shown. And what is the age group? Again, that is shown. So you will interpret this graph, and that would essentially be the of this particular task.
So I'll write that as if I'm reading it to somebody that can't see the graph.
Correct. Absolutely.
Yeah.
Absolutely.
Yeah. Okay.
And that's how you would find, it says discuss variability of data and main features of distribution. So here you're going to discuss what is variability, and you're going to discuss what is distribution. Now, distribution is of two types. So obviously variability tends to be, sometimes you say, the temperature varies. I use this term. So temperature varies or the data varies. So variability is basically range of data that you would take into account sometimes when you are undertaking research, or you're, say, for example, looking at problems. So sometimes you say, for example, if the United Utilities in Manchester came back and basically said that, the pressure of water on your taps varies. So, but they need to still maintain a minimum PSI of say 2.0 for the water to come out with some sort of pressure from your taps. So
Yeah.
they have an instrument which reads variability. A simple example I'll give you is you look at your boiler in the home. Now, you normally set a PSI on that boiler that it should not drop below a certain pressure, which is 2. If it drops below, it needs to be between 1 and 3, which is always green. That means the pressure of the boiler is okay and the heating is going to work. But if it falls below 1 or if it goes over 3, if it falls below 1, your boiler automatically stops. If it goes over 3, you're recommended to switch off the boiler and bleed your radiators so that the pressure falls into place. So you have to explain what is variability of data and why is variability important and what does it refer to, and theoretically explain. And then what are the features of distribution? First, you'll talk about distribution, then you'll talk about central tendency of distribution, and you talk about variability, how it comes into distribution. And you, if required, you can give a formula for distribution and its variability by talking about symmetry, skewness, and kurtosis, which is the technical formula for features of distribution.
So what's distribution again? Sorry.
Yes. So distribution is primarily, when you try and find out a central point or let's say, sometimes you use the term called frequency of distribution, right? Or if you say, what is the frequency of you visiting your GP once in a year, in the year, not once, but what is your frequency of visiting your GP in the year? So if I say, I visit the GP a couple of times, but if I say, can you define couple? And you say, okay, I visit maybe 3 or 4 times in a year. So that is the distribution. That means the frequency of your visits to meet your GP in the year is 3 or 4 times.
Yeah.
The main reasons why we talk about the features of distribution is that when we do want to understand if you've got large sets of data, for example, if I was to look at calculating the average expenses of a household in the UK for a year, and how much of that you spend on electricity, how much of that is on council tax, on fuel costs, on food and other things. So what you're trying to do is, first, you're trying to differentiate the objects or the different types of expenses in this case. And then you're looking at what is the frequency on which you spend. So sometimes you would see your missus or your partner makes a comment that, we on an average spend £200 on Amazon every month. We need to bring it down and maybe put that money elsewhere somewhere. But how has she calculated that frequency that we are spending on an average about £200? What she's doing is she's analyzing the data of certain number of months and then arriving at an average or a median value to say, give or take, in 1 month we spend 100, in the other month we spend 200, in some month we spend 300, but in 1 month we didn't spend anything. But if you look at an average, you are then trying to find out the distribution of how much you're spending across a number of months, and then you arrive at a figure, and that is what you try to do is you find out what is the variability and what is the distribution of expenses that we are doing. How much is on Amazon, how much is on food, how much is on electricity or fuel cost or other cost, and that will give you a distribution of your monthly expenses in the household. So it's an important concept that is used in statistics and mathematics, and that is what you need to explain by talking about the tendency, the spread, and obviously a formula which basically helps you understand if you have to calculate distribution, then you would be able to do so using that formula. And that formula has symmetry, skewness, and kurtosis as the 3 variables when you have to calculate distribution. So this task is to just explain these 2 terms. One, what is variability of data, and what are the features of distribution? If I remove the clutter in terms of the nonsense, in terms of the English sentence, like discuss and main features, what the task is asking me to do is talk about what is variability of data and what is the features, or even that, what is distribution? And then the features of distribution and maybe the formula of distribution. Okay. Now here, the next one talks about range of statistical diagrams approved for a variety of reasons when you have to collect data. So here, essentially what you need to do is talk about what are the various statistical tools which are available, which allow you to depict mathematical data in some sort of diagrams, which are used in statistics. And these diagrams are, when you use the Excel spreadsheet, we use bar charts, pie charts, stack bar charts, and those are bits that you have to explain theoretically.
Yeah.
Okay, it could be, I don't know, maybe I don't want to, let's say introduce complex bits, but sometimes we use what are called stack bar charts. So for example, if you want to show a distribution of income in the UK across, along with Germany, France, Italy, which are the other bigger economies, and you want to do it for 5 years, you would use a stack bar chart. That means a bar on which you will stack up the successive number of 5 years that you want to show. And then on one chart itself, if you're showing it for Germany, for Italy and France, along with UK, you can't have 4 bar charts, 5 charts for UK and then 5 bars for Germany. But if you want to show it as a collective data, then the useful part of the diagram to use using Excel would be to use a stacked bar chart, because you want to stack it up number of years and show, and the color of those stacks of bars would be slightly different to differentiate easily visually if some people see it. So there are different types of diagrams that we use. The most common ones that you are aware of is pie chart, bar chart, lines that sometimes we get to see, like stock exchange. When you look at how is the Apple share performing, it is, showing a line graph, how it is going up or going down or taking a dip, or inflation, how is it going up and down. When the Office of National Statistics shows, the trend for last 10 years, it will show using a line which is going up and down, and that's a line graph. Is that okay?
Yeah.
Now, the next part of it is a mathematical question. So it says calculate the following. The following data in the hourly pay is basically the hourly pay in pounds offered to shop assistants in a survey of job vacancies in June 2003. And this was based in Reading. Now, what it is asking you to do is calculate the mean, median, and mode of the data. So you need to have the formula. So let me write it down before I forget. So I will send you something called the formulae handout. Formulae handout. Okay, this handout will essentially have all these formulas that you need to know, which will allow you to solve these questions. It's not rocket science. You'll be able to get them on Google straight away, but we've got a 1-page, 2-page handout, and it'll be easier for me to just email them across to you. So when you talk about mean, what is mean? Mean is basically the sum of all the data points and divided by the total number of points. So if I have to find out the average wage across so many workers just for June, what I would do is start adding up everything, £5 for 2.21 up until 550, and then divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 21 divided by 21 would give me the average wage, hourly wage in pounds, which is being given to a shop assistant, and that would be the mean. Because what you do is, the means formula is you add all the values and divide by the total number of values. That's the formula.
So it'd be all them added together divided by 21.
By the total number of values. So total number of values, I think, is 21, and adding all the values, would add up to, I think, 40. So if you divide this first side, that is whatever it is, 40 odd, I think, is roughly 55 odd probably, and then you divide by 11, that is the average. And this is the second set of data. So it's provided you 2 rows. This is the first row, and this is the second. Right. So this is 11 values, whatever is the total, divide by 11. And this is the second set of values, divide by 10. And that will give you the total.
Right.
The second one adds up to about 40, 15, 20, 25, 30, 30 and 9, 39. Yeah, it adds up to, I think, 40. 40 divided by 10 is about 4.
Yeah.
Now, you have to use the same set of values to calculate median. Now, what is the median? Median is the middle value. Right? So middle value in this, if it is showing this, then this is the middle value, because you have 5 on this side, 5 on this side. This is the middle value, 5.29. That's and similarly in this, if you look at 4, and 4.8 and 210. So your middle value is going to be 550 here.
Yeah.
You're showing only 10. So you'll take the upper side of, rather than like when we round it off 4.5, you round it off to say 5. That is where you'll probably leave the 5 here and then take this as the middle value.
Okay.
And then when you talk about mode, what is mode? Mode is the most frequent value. So visually looking at it, what is the most frequent value that you get to see coming up? So it's £5, £5, 550 is twice, 5 is twice, and then you have 520 ones, 510 ones. So 450 is also twice. So in this case, the most frequent value is we have to identify the value that appears most frequently in the data set. So it could be either of the three. So your answer, if you pick out 450, is the right answer because 450 comes out 3 times, as you can see, is the highest. Yeah. It will not be 5, it will not be 550, it will be 450, which will be the mode in this case. And then similarly, if you pick out a mode in this, you have to look at £5, £5 is 4 times. Rest of the values are only repeated once. So that would be the mode for this particular frequency set.
Yeah.
Okay. So
Yeah.
now in this, it says, given the statistical distribution of the table, calculate standard deviation. So again, when we look at standard deviation, what we need to know is what is actually standard deviation. First, you need to know the formula of standard deviation. Then only you will be able to calculate what is standard deviation. So standard deviation generally tends to be, they have given you 2 values of variables here, which is xi and fi. So basically it includes variance and it includes what is called, the mean values, which are occurring across a set of data. So in order to compute standard deviation, what we need to know is what is the data points and what is the mean of those data points. And when we look at the mean of those data points, how it is spreading across the data set is what is required to be calculated. So if I look at the formula of, let me just standard deviation. Let me just have a quick look if I can find it on Google. Show you visually the formula of standard deviation. So if I look at this as a standard deviation, yeah, so I've got the visual formula of it. Let me bring it onto a slide. Slide and then share that with you. Image. Quick screenshot formula. So that is what is called standard deviation. Let me just bring you into this slide. So this is the formula of calculating standard deviation. So it is mu equal to under root of total, which is the summary of 2 variables which have been given, xi, which is each value from the population, and mu, which is the population mean, and it is divided by the size of the population. So if we go back to the table which has been given to you, you have 2 values which have been given to you, which is xi and essentially f or mu, the population mean. Now, in order to do this on the formula, what you'll need to basically look at doing is use this formula to calculate the mean. So let me just bring that as a screenshot onto the slide as well. Give me 1 second. So this is the data which is given to you.
Yeah.
On the slide. And this data, what we need to know is now we need to interpret what and where would we use this particular formula to actually calculate standard deviation. So this symbol mu is actually the pi signal is the symbol for standard deviation, right? I might call it sigma, basically sigma, or sigma equal to under square or under root of sum of, in brackets, xi, which is each value from population, minus mu, which is population mean, and that value is squared divided by n, which is the size of the population. Now, you can see xi is clearly given here, right? So what we need to do for xi is each value of the population. First of all, first and foremost, you will total all the xi's up. 61 plus 64, 67, 70, 73. That will become the value here.
Yeah.
Right? Now, when I look at fi, what we are looking at is, this is basically your size of the population. And what we will do is relate it to mu. So in this case, you look at whatever this value comes out, minus 5 squared by the total number, 5 plus 18 plus 42, 27, and 8, and that will come here. And this will then be a final square root to receive, or come out with what is called standard deviation. Okay, now I don't know whether you have a scientific calculator, but if you do have a scientific calculator, basically what we need to be able to do sometimes when you look at the symbols of how, say for example, standard deviation is calculated, you would normally look at a simple formula, and that simple formula would basically give you two values. So one of them is xi, the other is mu, and then when you total it up, that is the n, the total size of the population. And that would allow you to straight away calculate this as a mathematical, let's say mathematical question. So if let me just try and see if I can bring something over to, just give me 1 second. Let me just try and see. So in this case, what we are looking at is, let me 1 second. So if I was to solve this, solution of this particular problem, what I would do is, so first things first, what I need to do is calculate the mean as per the formula mean, which is basically your mu symbol, which is given here, right? And that I need to calculate. So mu, which is, if I go back to this side, the mu symbol I need to add up. And that symbol, if I add up, I need to first calculate by adding these values here. That is primarily the mu. And then what I need to look at the variation. So the second point that I need to do is calculate variation, which is essentially the sigma symbol, if I write it down here. And then finally, what I would do is use that formula to calculate the standard deviation. And that would be the problem. But I would need, a scientific calculator, because I need to calculate the under root. And obviously this value, which is total of this minus the total of this squared, would actually divide by the total value of this, would actually give me that. So you need a calculator. So if I look at, just very briefly, the total of the first row, 61 plus 64 plus 67 plus 70 plus 73, that works out to be 335. And then underneath, which is 5 plus 18 plus 42 plus 27 plus 8, and that's 100. Now, what I need to do apart from that, for that, is to basically look at 335 minus 100, which is 235, the square of 235 divided by 100, which is this total. And then I have to take a square root of it. And that will give me the standard deviation. So if I use a scientific calculator, I'd be able to arrive at an answer which is coming out to be 2.92. What is the standard deviation of this particular question and its answer? in terms of the Word, how would you do it on the document? You're going to explain this exactly the way I'm doing on the PowerPoint slide here.
Yeah.
Is that okay? Because obviously,
Yeah.
show the calculation of it. So what you have to do is basically describe the steps that you have taken to be able to solve this question. So it says 1 into workbook in Microsoft Word format. Right? That's how you show the output of all these mathematical questions in order to calculate some of the tasks which are given.
Yeah.
Is that okay?
Yeah.
Good stuff. Any questions? Any place that you want me to go through or repeat?
No, I think I've got it, to be fair. I've just about sussed it. Are you going to send me the calculation? The equation for that one about the balls I was struggling with?
Yes. So what I will do is I will send you the set theory handout,
Yeah.
just writing it down, and then I'll send you the formula handout, right? And then
Yeah.
the recording of this session.
Yeah. Oh, yeah. I forgot you to do that. That'd be brilliant.
Is that okay? I'll
Yeah.
see
Yeah.
you just after this session in a couple of minutes, because the other two attachments I've already got ready in the email. But once I stop recording, it'll take a couple of minutes for it to finalize on Zoom, and then I'll send you a link of that recording in the email.
Yeah. That's fine. Thank you.
Okay.
Yeah.
Good stuff. No worries. And if you need any further, say, for example, reading on it or any additional details, then do let me know. And what I will do is, I think I will be able to send you some knowledge or activities, which are basically activities with answers for you to try out and obviously, perfect some of the bits in terms of understanding by doing those exercises.
Yeah. Yeah. I struggle with like reading and actually understanding. So like I've read through it but not fully took it in. So after actually talking to you and you explaining it, I think I've understood it a lot more.
Right. Okay. No worries. But if
Right.
you need anything additional, then do let me know on the email and I can come back to you pretty much, straight away.
Yeah, yeah, that'd be brilliant.
Good stuff.
Right.
Thanks.
Thank you very much.
Thank you. Take care, and I'll speak to you soon.
Yeah. Cheers. Bye.
Bye for now.